So we are going to start with a new chapter today. So we have talked, I think, a good amount of time on petroleum geology. Now we will start with coal geology, but of course there will be some more external presentations on different aspects of petroleum geology in following weeks. So one of them I have announced today, which will be next week, and that is use of artificial intelligence in seismic interpretation. Be a fun topic. Uh, so yeah, please join in. All right. So let's just begin, and let's wait. I mean, let's let others catch up their own time, else they can see the pre-recorded. I mean, the video. So as I was saying that we are going to start with coal geology today. And today we are going to discuss some of the introductory aspects of coal geology. Just a moment, let it fired up. Presentation in the presentation mode, and then I'll begin. Can you see my screen, everyone? Can just someone tell me if you can see my screen?
Yes, sir.
Okay, strange. So which slide do you see? Introduction to the first slide, do you?
So we see the first slide, but not in presentation mode.
Don't know what is that.
Like not in presentation mode, sir.
Yeah, I'll just. Yeah, now.
Yes, sir.
And if I write, do you see that as well?
Yes, sir.
Okay, fantastic. So we are going to start with coal geology. Of course, as I have been saying, the textbook that you have to follow is called Textbook of Coal, Indian Context. And the author is Chandra and Singh. So this book is available in the library. I don't know if they have already made the e-copy for it. If not, please ask them to do so. Okay. And you can see here two beautiful pictures of mining activities of coal. Okay, you can see like a horse cart in the very earlier days when coal was being excavated. So coal is kind of being transported in this horse cart. And this is the picture of a beautiful open cast mine. We will see there are two types of mines we will read about. One is open cast mine, the other one is underground mine. Here is an open cast mine because you can see the whole mine from the top. I mean, only the undercover, only the overburden has been removed, and you can essentially see the coal seams. And this happens for shallower coal seams when we try to excavate them. It's beautiful. These you can see these benches, and these benches have been excavated to take coal out of it. So, what is coal? So it's a form of rock rich in organic carbon. Okay, that is an important point to remember. A rock which is rich in organic carbon. In earlier days, when I don't know, these sort of questions are generally asked in exams, whether you classify coal to be a rock or not. Okay? Whether you classify coal to be a rock or not, and then you have to add certain pros and cons against that argument. Okay. Nowadays, I don't think anybody asks that question because coal is coal. I mean, why do I have to essentially put it into some bracket? But nevertheless, let's just discuss whether we can classify coal being a rock. Okay, so if I see the derivations of a rock, so rock has to be naturally occurring, and we will see if that plays for coal as well or not. So naturally occurring, then it has to be inorganic, and then it has to be assemblage of of minerals, right? So of course, coal is naturally occurring, right? I mean, you cannot really create coal by in the laboratory, but it's not inorganic. It is of course organic, right? It's the organic carbon. When plant matter, you have read in your high school that it generally forms by the dumping and the qualification process of land plant, right? So it's definitely not inorganic. So that is not true. It's whether it is an assemblage of minerals. Well, they are not assemblage of minerals. There is a special term which is used for the different components of coal, which we call macerals. We will see what macerals are, but they are certainly not minerals. Okay, there are some inorganic minerals present in coal, but that is not the major component. The major component of coal is called macerals, but that is organic in nature. So if someone asks you this question, then you have to justify that there are few things which are resembling like a rock, but then there are things which are not essentially very much similar to a rock as well. But one of the things that you of course know, that coal forms in sedimentary basins. Okay? In sedimentary basins, yeah, and then you often find, say for example, I have few layers. So maybe one is shell, then another is sandstone, maybe here is coal, then I have coal, and then perhaps another sandstone. Okay, so it follows beautiful stratigraphy like we see in a sedimentary basin, but then it is not organic. Sorry, it is not inorganic after all. Okay. So able to be burned as a source of energy. That is another important point. We all know about it. We have seen our mothers to maybe you have not seen, but we had seen burning coal and using it as a fuel. But still, coal is one of the primary sources of energy, right? So most of power plants, the power plants in India, most of the power plants, I think 99% of them are actually coal-fired power plants. Okay, so a power plant can be a coal-fired power plant or it can be a gas-fired power plant. So how you generate electricity, you have to rotate your turbine, right? So how do you rotate your turbine? You have to provide some energy, right? And that energy you can get it from burning coal or burning natural gas. Hydroelectricity is different. There also you rotate a turbine, but you rotate the turbine by the force of a river, right? By force of water. But in case of fire power plants, of course, it can either be from a coal fire power plant or a gas fire power plant. But most of the power plants that we see in India are actually coal-fired power plants. Okay, so coal, I mean, necessarily has a lot of importance in the energy budget of India. Coal India is one of the most profitable companies of the government. Okay, so and there are so many aspects and controversies related to coal because it is such an important natural resource. Okay, so it typically contains organic carbon. The organic carbon can be rings or straight chains. We will see what are they later on. It also contains a little bit of inorganic element. Majority is organic carbon, but little bit of inorganic element. Like they're called, like it could be iron, aluminium, clay minerals, calcium carbonate, and trace metals. Okay, and these when they are burned, so carbon becomes carbon dioxide, carbon becomes CO2, of course. Okay, and CO2 and H2O. Okay? And the inorganic elements, of course, um, form something we call as ash. Okay? So if we burn the inorganic element, then it forms ash. And so having more mineral content inside coal is not good, because this when you burn these inorganic elements, it doesn't necessarily release a lot of energy. So having less amount of inorganic elements in coal is better. And then of course it contains water plus some volatile matters. We will see what are them. Volatile matter. Now, water is of course H2O, but volatile matter is anything that vaporizes while you burn coal, anything that vaporizes that you burn coal, which is not H2O. Okay? That is what is volatile matter. We will see what are they. So if you do an elemental analysis of coal and you have heard the different types of coals, say namely bituminous, I'm sure you know the name anthracite, and this is a typical uh, chain carbon that you observe there. Very high percentage of carbon, then hydrogen, oxygen, nitrogen, and sulfur. In anthracite, of course, you can see that the ratio of carbon has essentially increased. We will see why that happens later on. So different forms of coal. So the first one is anthracite, and then you see bituminous. Let's just put all of them together: subbituminous, lignite, and peat. So we will start from peat. So I have the precursor of coal is of course wood or plant material, which goes through the qualification process of burial due to burial. So wood and plant material, which is when it is buried under the earth, and it suffers certain pressure and temperature, and it goes through this uh, process of qualification. So it initially creates pit, then it forms lignite, which is you know little bit matured coal, then subbituminous, bituminous, and anthracite. So this is almost like something in between the plant material and coal. And then this is the real coal actually starts from lignite, and then subbituminous, bituminous, and anthracite. But you can observe that with uh, so what is happening here essentially, we say that the rank of coal is increasing. Okay, so this is essentially we call that the rank of coal is increasing. So the maturity of coal is increasing. Okay? The other way of expressing it is the maturity is increasing. And we will see what are the different chemical process that it takes through, the different physical and chemical process that it goes through while it actually transforms into lignite. Lignite transforms into subbituminous, subbituminous to bituminous, and then anthracite. But one thing you can see that with maturity, the luster of coal is actually increasing. So anthracite is extremely lustrous, okay? Very, very lustrous. So it reflects almost like it has metallic luster, metallic. But then you can see for lignite and peat, it's very dull. The luster is dull. Okay, now if we look into them uh, little more detail. So peat, which is not quite coal, which is used mostly for home heating, contains less than 60% of carbon. The heat value of it is 8 mbtus per pound. Okay, BTU stands for British Thermal Unit per pound. Now then there is lignite, which has carbon content of 60 to 70%. Heat value you can see ranges between 4 to 8.3. Why it is used for? Sometimes for electric generation, you can use lignite as a fuel in your power plant station. The least mature form of coal, it's the least mature form of coal, geologically may contain almost 70% of water. Okay. So you know about Kutch, which is in Gujarat, in Western India, that contains a very, very large deposit of lignite, almost unexploited. So then comes subbituminous, which contains around 71 to 77% of carbon. Heat value around 8.5 to 13 mbtu per pound. Okay, it is also used for electricity generation, and you find them mostly in Western US, India, and China. Yeah. So India has a very, very large deposit of subbituminous and bituminous coal. Okay, so we will see where they are. Madhya Pradesh, then your Chhattisgarh, Bihar, Jharkhand, West Bengal. This whole Gondwana basin is full with subbituminous to bituminous quality coal. Okay, China is also another major coal producer. So is the US. Okay, and then bituminous coal, of course, 77 to 87% of carbon. The calorific value also increases. It's also used for electricity generation and used for coking of steel, coke for steel. Okay, so I don't know if you have read it already in your basic metallurgy or somewhere in school, that when you take iron ore and then you create raw iron from it, you have to burn your iron ore with some coal, and that coal is called coke, and that has to have certain rank. It has to be of the bituminous range. So coal is not only used for electricity generation, but it is a very, very important and vital component of iron ore industry as well. Okay, so you find bituminous coal, as I said, also in the US, India, and China. Okay, and then anthracite, which has almost more than 87% of 87% of carbon, very high heat value. But you can see that anthracite is not very well used for electricity generation or for making coke for steel. Why, we will see later on. One of the primary reason is, uh, amongst many, is anthracite is not as common as bituminous. Okay, but hence their typical use is for home heating. But there are some other reasons. When we see them, when we will look into them in detail, we will see. But primarily, anthracite is used for home heating. Okay, where do you find them? In the US, but very little in India. Right. So let us just look at few of the units. So one British thermal unit is equivalent to 10 to the power 5, 10 to the power 4 joules, I guess. Yeah, 10 to the power 4 joules. Okay, and so if you want to understand what it means, so one wooden kitchen match produces approximately one British thermal unit of energy. So, and then Air conditioners for the households uses typically produces between 5,000. It's not produces. It's actually consumes between 5,000 to 15,000 British thermal unit per day. 1 cubic foot of natural gas produces approximately 1,000 British thermal unit of energy. Okay. So some of the carbon components, as we have been talking, are volatile. We call them as volatile matter or PM. Yes, so this is the gaseous part of the coal, and they are inherent. They are present in the coal itself. Okay, but when you heat them, they are out from the coal structure. Okay, they are generally absorbed in the coal structure. Okay, and then when you heat them, they are actually driven off from the coal structure. So these are the volatile matters which are non H2O. Okay, non H2O. So so the H2O component is called moisture. The gaseous component, which is also absorbed in the coal structure, is called moisture, and non H2O component, which is primarily hydrocarbon, basically. Okay, that is what we call as volatile matter or VN. Okay? That is driven off when the coal is heated more than 950 degrees centigrade temperature. Some components condense to form oils and tars when cooled. So you can actually collect them, and form a little bit of oil out of it. More in lignite, subbituminous, less in anthracite. So with the qualification process, with maturity, coal essentially loses this volatile matter from its structure. So an anthracite will contain less amount of volatile matter than a subbituminous coal. Right? So then that's why the bituminous is generally subdivided into low volatile bituminous, and high volatile bituminous. Okay. Of course, high volatile bituminous is less matured than low volatile bituminous because with temperature, the volatile matter content essentially decreases. With maturity, volatile matter content essentially decreases. Coals are divided into 22 classes based on volatiles, but you don't have to essentially know about them. But you can simply remember low volatile bituminous and high volatile bituminous. That will be enough for you. So, with respect to the amount of carbon present in, or with respect to its maturity, which is expressed by the amount of carbon present in coal and volatiles present in coal, we can subdivide coal into basically, 4 categories or 5 subcategories, if you like. So peat, then lignite, then bituminous, of course, is further subdivided into subbituminous or high volatile bituminous coal. This is also high volatile, and then bituminous coal, and then anthracite. Okay? And bituminous is essentially low volatile. So if you look at with rank, essentially the percentage of carbon is increasing. This carbon is also called fixed carbon. Okay? And with maturity, the amount of volatile matter is actually decreasing. Right? So with rank, the fixed carbon increases and the volatile matter decreases. Okay? And that makes sense because this is, with the progress in qualification process, of course, it will be enriched in carbon and it will be depleted in the volatile matter. and also with rank, your per pound heat value also increases. Okay, as you can see in this particular chart. So anthracite has the maximum heat value or calorific value. Heat value is also called calorific value. Okay. Now then, depending on the presence of the ash within within the coal. So ash means is the mineral content, right? The inorganic part of the coal, the inorganic matter in the coal. So as I said, if the inorganic matter is very high, the quality of coal is actually compromised. Okay. So a low quality coal is where I have more than 30% of other inorganic matter, I mean, including sulfur, and more than 3% of sulfur. Why I am treating sulfur differently? Because sulfur is actually pretty dangerous. Okay. When sulfur actually burns, it creates sulfur dioxide, and from sulfur other other for example, within the mine, if I have high sulfur, it also emits H2S, and H2S and sulfur dioxide both are extremely you know toxic gases, right? Very toxic gases. So it can harm the life of people who are actually are involved in coal operations. So you want your coal to be having very low sulfur content. So increase in sulfur content means it increases added risk with respect to its safety, and then hence the quality of the coal is thought to be decreasing while the sulfur content is more. Okay, then medium. So if more than 30% ash, we call it low quality um, coal. If the sulfur ash content is less than 30%, we call it less than 30, more than 10%, we call it medium quality coal. And then if ash content is less than 10%, we call it as we call it as high quality coal. Okay, so why this is called ash? So say for example, I have a coal block. Okay, this is my coal, and then I burn it. All the hydrogen and carbon component will be forming CO2 and H2O, and will actually leave the system out. But whatever will be left as ash, literally ash, okay, that is nothing but the inorganic matter. Okay, so if you weight this inorganic matter, the weight of this inorganic matter will be directly proportional to the amount of, sorry, the weight of the ash will be directly proportional or very close to the inorganic matter present inherently within the coal, right? So hence the percentage of inorganic matter is expressed by ash content. So this is a very important parameter. We call it as ash content. Okay. Now, whatever whatever we have learned so far. So coal has few components. The first one we will call it as fixed carbon, and then volatile matter. That's the non H2O component, and then moisture, and then of course ash. So this is what are the typical constituent of coal, right? Fixed carbon, that's the actual carbon present. Volatile matter is the not the gaseous thing which is essentially adsorbed into the coal matrix, which is non H2O, and then moisture, which is absorbed and absorbed within coal, which is primarily H2O, and ash is nothing but the mineral matter or the inorganic part of the coal. Okay. So now, if we in the industry, because scientists look at it from one point of view, like volatile. I mean, the thing that we have discussed so far. But the classification of there is a pragmatic classification that is used for coal in the industry, because it's one of the primary component used in any industry for that matter. Okay, in the metallurgical industry, in the power plant, all these heavy industries have huge use of coal. So hence they have their own classification. So and the classification goes like this. So in the right hand side, of course, from left to right, the carbon or the energy content increases. From right to left, the moisture content increases. Okay. So if the moisture content is high and carbon and energy content is low, we call it a low rank coal. And if the carbon content is high and the moisture content is low, we call it hard coal. Okay, so hard coal means good coal. So low rank coals are further subdivided into lignites and subbituminous coal. The lignites are used for power generation, as we have discussed before. Subbituminous coal is used for power and cement. And then hard coals are primarily subdivided into bituminous coal and anthracite coal. Bituminous coal, thermal. So this is for primarily creating electricity. So the coal which is used for creating electricity, are called also steam coal. Okay, so if someone calls you steam coal means the one that will be primarily used for creating electricity or generating electricity. And that is the same also used for in the cement industry. And then the metallurgical coal, which we call as the coking coal. And but the anthracite that is used for domestic uh, domestic purposes. Now you can see in the industry, okay, 52 plus 30, that means 82% of the total coal which is used, okay, are actually bituminous to subbituminous range. Okay, so hence most of the studies on coal are also based on the bituminous coal, okay, bituminous and subbituminous coal. Okay, but another thing you will find that the bituminous coal, as we will see that in a moment, that the bituminous coal has distinct layers within them. Some layers are extremely bright and some layers are dull. Some layers are lustrous, okay, and some layers are dull, lustrous and dull, like a beautiful stratigraphy developed within the coal. And this is what we call as banded coal. So bituminous is typically a banded coal. And anthracite, in that coal, what you will find that this banding is kind of lost. Okay, there is no banding. So this is called non-banded coal. Non-banded. Because of the heat, this individual beautiful banding in coal is kind of lost. Okay. Banded coal is also called humic coal. Banded coal is also sometimes called humic coal. And non-banded coal is also called sapropelic coal. Sapropelic. Sapropelic coal. Often called sapropelic coal. Okay, so any coal contains moisture, ash, volatile matter, fixed carbon, and then in, of course, in insignificant amount. I mean, you can also put this sulfur into ash, but you can treat sulfur differently. Sulfur, and then of course it has the calorific value. These are the few. So when you say, for example, you own a coal mine and you want to sell your coal, so it will have its certain specifications, right? So for example, if you design clothes, right, or not clothes, say for example, you sell some sort of health drinks. Okay, so when you package that health drink on the outside of that package, you have to put the specification of the of the health drinks, right? So this contains this amount of sugar, 10% of sugar, 5% of calorie, and 300 kilocalorie of calorie, and then 5% fat, this percent protein, and so on and so forth. Similarly, when you own a coal mine and you want to actually sell your coal to anyone, you have to specify your coal against this property. So you have to say what is the general moisture content of your coal, what is the general ash content of your coal, what is the volatile matter content of your coal, fixed carbon content of your coal, whether it is high sulfur coal or a low sulfur coal, and what is the typical calorific value of your coal. Okay, and of course, if I have this being high is better, this being high is better, but these being low is better, right? These being low is better. Sulfur being low is better. Now, there are other specifications that you can also add to it. So you can say, you can express your total, you can express the moisture content as total moisture or as received. That means you take out the coal from the mine and you sell it. So that is the total moisture content. You don't do any treatment with your coal. Now, what you can do, you can dry your coal on hot air for some period of time, okay? And you can get out some percentage of the moisture. Okay, so there are specifications which are given that you will be allowed to expose your coal under hot, dry air, and some percentage of moisture can be removed out before you actually sell it. So you can then say my coal is actually air dried, and then the moisture content is such. Inherent moisture content is such. It only contains the inherent moisture. So moisture is actually the surface moisture and the inherent moisture. Okay, inherent moisture. So what air drying actually does, it takes out this surface moisture. So whatever moisture is left within your coal is the inherent moisture, which is deep inside the coal structure. Okay, that you cannot simply remove by air drying. Okay, air drying only removes the surface moisture. So when you say my coal is air dried and you sell it, you say that you have actually removed the surface moisture, but it still contains the inherent moisture. Now, dry basis excludes all moisture. So it doesn't necessarily mean that you have removed your inherent moisture, but you can make some calculations. Say you can say if I have 10% of surface moisture, that means I can expect that the coal has 20% of inherent moisture. Okay, so when you sell your coal on dry basis, it doesn't mean that you have dried it completely, but you can make a calculation and you can say that my on dry basis my coal is coal contains this is a dry basis coal, it contains insignificant amount of moisture. So when you exclude the moisture and then you express the other terms with, I mean, removing that moisture amount. Okay, what do I mean by that? Say for example, I have fixed carbon of Fc of 30%, surface moisture of 10%, then inherent moisture of 20%. How much? 30, 60. Ash is 10%, and volatile matter is 10%. So I can simply say that and say this is as received. Okay, then I can essentially get rid of the surface moisture by air drying. So then what I am left with, actually surface moisture is gone. Then I have to recalculate this value against 100% because this is now totally 90%, right? because this 10% is gone. Then I have to, express again FC in 30 by 100 multiplied by 90, right? This is how I have to calculate my FC. And similarly, I have to calculate it for everything, right? For IM and for ash, for VM2. Okay. Then I can say that, look, although I have not removed the inherent moisture, but if you remove the inherent moisture, then your fixed carbon percentage is this, your then your ash is this, and your VM is this. Okay, so that will be your IM. And then you can say dry ash free. Similarly, you can exclude all moisture and ash. So what is left with? Only fixed carbon and volatile matter. Okay, it doesn't necessarily mean that you remove your moisture and ash. You just calculate it in such a way that you express out of that percentage. Say if I have, so in this particular example, if I take out all the moisture, that means 30% and 40% I have gone. So I'm left with 40%. I'm left with 20, 40. So I'm left with actually 10%, 20, 30, 10, 40%, 50. So this is actually 50%. Okay. So, I'm left with 60%, right? So I'm left with 60%. So that means I have to now express 60% for 100%, right? And I can express my total amount of coal. I mean, different components of coal out of that 60%, and I can say that this is dry ash free. Okay. Let me see if we have any questions so far. Was this point clear for you? How they are expressed? Everyone? Can someone just tell me, was it clear how this dry ash free, okay, volatile matter free, and moisture free things are essentially expressed? Good. So let's now see how coal is created. And I think most of us by now know how coal is created, of course. So, the way fossils are created, coal is created exactly the same way. Okay. So from special form of fossilization of plants that lived hundreds of millions of years ago. Okay, so Carboniferous, Carboniferous and Permian, the time of land plant boom. So that was the time when everything, I mean, the world was completely governed by big, very big land plants. And that's why you find most of our coal deposits also come from either Carboniferous or from Permian. Okay, there are other deposits as well. Say, for example, in the Mesozoic, you also have coal. Some deposits. In the Tertiary, also you have coal. But the best bituminous quality coal and the voluminous quality coal actually comes from either Carboniferous or Permian. Hence, the name actually Carboniferous came. It comes from carbon. Yeah. So and the process is very very similar, very similar to what you can imagine. All those, there were land plants everywhere in the swamps, in the land, and then those died. Got dumped, and then there were very quick burial, and with pressure and temperature that form peat. Peat you can actually form today as well. Maybe 50 or 60 years if you keep some the land plants down below your soil and keep it there for it forms actually a little bit of peat substance. Okay, and then from peat with increasing pressure, temperature, heat, and time, of course, it formed lignite. From lignite, it created bituminous and subbituminous and bituminous coal, and then anthracite. What you see in this particular cartoon, that with the maturity, of course, there is a large compaction going on. Yeah, everything is kind of compacted. The carbon, though, is not decomposed. If carbon would have been decomposed by bacteria, what would have happened? Carbon would have created CO2, right? So you would have not seen that fixed carbon present in coal. So the importance here also is you have to create an anoxic environment. So that's why you need, of course, rapid burial. So the land plants by some catastrophe, get dies, and then by some process, the maybe the sea, there is a transgression, the sea moves to the land, and there is a large amount of clay deposited over the land plant. Yeah, and then you see those plants are actually converted into coal. Hence, so if I just try to explain that, say, so it needs land plants, right? Needs land plants to form coal. And here is your sea. Okay. So these trees have to die, and the sea has to essentially transgress so that it can actually put a cover. Okay, put a, so now they are dried, they are dyed, and then put a thick impermeable cover on the top of it. So the sea essentially transgresses to the land. So it is kind of an unique situation that I need to have land plants as well, but the sea will also have to move enough so that it can, you know, cover it up. So now if I ask you, say for example, I have these beautiful jungles of Satpura, beautiful preserve of land plants, right? And then I have the mangroves of Sundarban. Yeah. Which one do you think would have better chances of creating coal? Can someone tell me? So I'm giving you two situations. One is the Satpura jungles, and the other one is, Sundarbans. Okay. And what type of plants do you see in Sundarbans? They're not very big. They're mangroves, right? You see mangroves there. Sundarban is a typical example of a swamp. It's a delta. Now tell me, if I say, for example, like after a few 100 million years, we are not there. Maybe another species is roaming on the earth. Okay, and they also need coal. Where would you suggest them to dig? Somewhere where Bhopal was, or the Satpura mountains are today, or would you advise them to drill or dig in the Sundarbans, that the Sundarbans are now today? What would be your bet? Can someone tell me? Hmm? Shavik, tell me, where would you ask them to dig? Near Sundarbans or near Jabalpur, for example, or Itarsi, where the Satpura Mount, or Pachmari, where the Satpura mountains are? Where would you ask them to dig? In other words, where would you most likely find coal? Shavik, come on. This is a strange situation. When I ask questions, the students disappear. I start seeing the number of participants decreasing one by one. Okay, Alok, tell me, where would you get more coal? Where is the chance? Where is the potential of getting more coal? Is it at the Satpura mountains or is it at the Sundarbans?
The Sundaran.
Why? You are right, but why? Come on,
No idea. No idea, sir.
no idea. Then why did you say Sundarban? Okay, let me ask Gopal. Tell me, where would you find more
Yes,
coal?
yeah, in Sundarban because it's like closer to the sea.
And what that does?
Uh,
If it is closer to the sea, what happens?
Sir, I didn't follow the earlier discussion, but like
So if it is closer to the sea, what will happen? It will be easier to actually have transgression there, right? Transgression means the sea level will be up. So with a
yes,
small sea level up, the Sundarban will be inundated and shale will be starting to deposit. Okay, and
hmm,
that will create an anoxic environment over the plants which are being died, which are dying. Okay, so it will create that anoxic environment because of the easy transgression. Okay, although in the interior part of the land there are more lands there. Okay, if they die, they will be there exposed. I mean, you can go and see in the forest now. If a plant actually dies, what happens? Does shell come and cover it up? No. Where would shell come from? There is no source. It will just stay there and then be degraded by the bacteria, and carbon dioxide will form and it will vanish in nature, right? So it will not be preserved. So if you have to preserve that land plant, you have to have the inundation of the sea. The sea must come up and then cover it up with its shell cover on the land plant which has been died. Okay, because it has to preserve. Hence we find more, the chances of finding more coal is in the swamp. Okay, is that clear, everyone?
yes, yes, sir.
Okay. All right, so let's just stop the discussion here, and we will continue with the geology of coal tomorrow. Okay, unless if you have a question. Anyone, any question? Okay, if not, then I will stop it here and I will see you tomorrow. Thank you. Bye.